Just days after OpenAI's unveiling of GPT-4o on-device capabilities and Google DeepMind's latest AlphaCode advances, the race for AI infrastructure has never felt more urgent. Hyperscalers around the world are scrambling to secure the fastest, most efficient hardware to train ever larger models, while navigating geopolitical headwinds that threaten to cut off entire markets from critical supplies. In the midst of this whirlwind, one announcement has quietly upended industry expectations. Huawei has begun shipping its Cloud Matrix 384 supercluster, a system explicitly designed to go toe-to-toe with NVIDIA's top-end offerings. Today, I'll walk you through why Cloud Matrix 384 matters, not just as another data center upgrade, but as a statement of technological sovereignty and strategic resolve. From its massive 67% throughput advantage over NVIDIA's NVL72 to the hidden costs in power and software integration. We'll explore how Huawei built and delivered 384 Ascend 910C processors in record time, and what that means for the future of global AI development. So let's dive in. It's official. Huawei has quietly begun delivering its flagship Cloud Matrix 384 AI supercluster to key domestic customers, just weeks after its public unveiling. That speed alone is remarkable in an industry where 6-month lead times are often lauded as fast. But more compelling is what Cloud Matrix 384 represents: China's first large-scale AI system explicitly designed to rival NVIDIA at the top end, filling a critical gap left by U.S. export controls. As data centers scramble to replace banned H20 systems, Huawei's latest launch signals both engineering prowess and geopolitical determination. Here's a breakdown of what makes Cloud Matrix 384 so disruptive, and the trade-offs that come with building 384 chip clusters at scale. Cloud Matrix 384 interconnects 384 Ascend 910C AI processors, each fabricated on SMIC's 7nm node, to deliver aggregate compute and memory resources that eclipse NVIDIA's current flagship cluster, the NVL72. According to insiders familiar with early deployments, delivered units are already running inference and training workloads for major Chinese internet and cloud providers, with at least a dozen systems sold so far. That footprint may seem modest next to the hundreds of NVL72s powering global hyperscalers, but it marks the rapid emergence of a homegrown alternative at the very top tier of AI infrastructure. In head-to-head comparisons, Cloud Matrix 384 offers roughly 67% more raw teraflops for large matrix multiply operations, and more than 3 times the total on-chip memory capacity versus an NVL72 cluster built from 72 GB 200 Grace Blackwell GPUs. Huawei achieves this by scaling up chip counts rather than pushing individual die performance, then tying them together via its proprietary linear pluggable optics interconnect. With 6,912 LPO transceivers delivering 800 GB per second each, the system provides over 5.5 PB/s of bidirectional bandwidth, outpacing NVIDIA's NVLink powered clusters by a factor of 2.1 times on scale-up workloads and 5.3 times on scale-out scenarios. Those figures aren't marketing fluff. They come from a recently reviewed Huawei presentation corroborated by multiple data center engineers running cloud-native benchmarks. Yet the architectural choice to use hundreds of mid-range chips rather than tens of ultra-dense GPUs brings unavoidable compromises. Cloud Matrix 384's energy draw is staggering. At peak training loads, it consumes approximately 559 kilowatts, compared to just 145 kilowatts for an NVL72 cluster, translating to 2.3 times less efficiency on a per floating point operation basis. Over a typical 3-year service window, electricity costs alone could be 2 to 3 times higher, even factoring in China's relatively low industrial rates. That said, domestic power prices remain below Western levels, and Huawei's internal analyses suggest total cost of ownership falls within 10 to 15% of an NVIDIA solution once all factors, chip procurement, network gear, and manpower, are included. Speaking of manpower, there's another hidden cost: software. Huawei's compute architecture for neural network stack has matured rapidly over the past year. but it still lags NVIDIA's CUDA ecosystem in tools, libraries, and community support. Customers report that deploying large-scale AI services on Cloud Matrix requires 3 to 5 times more dedicated engineering hours, especially when optimizing custom kernels or integrating with popular frameworks like PyTorch and JX. On the flip side, Huawei offers tighter vertical integration, from silicon design and fabrication through optical networking to data center rack orchestration, and guarantees cross-stack compatibility, which simplifies end-to-end performance tuning once the initial learning curve is overcome. Producing 384 chip clusters at volume demands ruthless efficiency on the manufacturing floor. Ascend 910C yields have more than doubled over the past 6 months, from under 20% to over 40%, thanks to wafer probe innovations and better defect mapping. That surge in yield underpins Huawei's ambitious plan to ship over 100,000 AI accelerators by the end of 2025. Meanwhile, the company has quietly sampled its next-generation Ascend 920, built on SMIC's early 6nm process, boasting 900 teraflops of single precision performance and 4,000 gigabytes per second of on-chip bandwidth, a 30 to 40% jump over the 910C. Taken together, these developments underscore a broader strategy: build a full-stack AI ecosystem insulated from U.S. technology bans. By owning everything from chip IP and fab tooling to optical interconnects and AI compilers, Huawei aims to lock in customers with end-to-end service agreements that span hardware refreshes, software updates, and on-site technical support. For Chinese cloud giants facing an uncertain future with NVIDIA, that proposition is hard to ignore, even if it comes at a higher upfront license fee. Of course, no technology exists in a vacuum. NVIDIA has warned investors that U.S. export restrictions could cost the company as much as $5.5 billion in lost revenue this fiscal year. In response, NVIDIA is accelerating development of lower supply chain risk GPUs, exploring alternative foundries, and deepening partnerships in friendly jurisdictions. Meanwhile, Western hyperscalers are evaluating fallbacks from AMD and custom ASIC providers, and even consortium approaches where multiple chip vendors pool R&D efforts to hedge geopolitical exposure, all of which raises a key question. Will AI infrastructure fragment into divergent spheres of influence? Today's superclusters still speak common programming languages and frameworks. But if Huawei's ecosystem gains critical mass, we could see runtime incompatibilities force Chinese developers onto domestic platforms. That, in turn, might prompt Western clouds to double down on NVIDIA's CUDA and bespoke interconnects, igniting a technical Cold War over AI software standards. Geopolitics aside, Huawei's Cloud Matrix 384 milestone is undeniably impressive from an engineering standpoint. Shipping hundreds of racks, each hosting dozens of optical switches and dozens more power delivery modules, within weeks of specification freeze, is a feat few companies, if any, could match. It demonstrates what can happen when government policy aligns with corporate R&D funding, targeted subsidies for SMIC, guaranteed purchase orders from state-backed hyperscalers, and expedited safety certifications. Yet the broader lesson is cautionary. Over-investing in scale at the expense of per-chip efficiency could saddle Chinese data centers with unsustainable power bills just as they expand into ever larger model training, where energy use is already a blistering concern. The industry's pivot toward more energy-proportional designs, where idle GPUs sip just a fraction of their peak draw, has barely begun. And Cloud Matrix 384 looks to double down on raw throughput without addressing the idle time penalty. So what's next? Watch for real-world benchmarks from independent labs, and any signs that Huawei's all-optical LPO fabric introduces unexpected latency or compatibility headaches. Keep an eye on Ascend 920 availability. Its rollout will reveal whether SMIC's nascent 6nm yields can keep pace with AI's insatiable demand. And listen for NVIDIA's countermoves. Will the company unveil a next-generation Grace Blackwell variant optimized for minimal export control exposure? In the end, Cloud Matrix 384 isn't just a hardware product, it's a statement. It says that China intends to break NVIDIA's stranglehold on AI's most advanced workloads, and it has the supply chain resilience and engineering muscle to try. Whether that gamble pays off economically or whether it instead drives a rift in global AI standards remains to be seen. But one thing is certain. The AI infrastructure arms race is no longer a two-horse contest, and the track has just gotten a lot more crowded.